our heading is terminology. In the terminology, the first thing which comes is aperture. Aperture. What is this aperture? The aperture is the effective width of the spherical mirror from which reflection of light can take place is called aperture. That means all the available reflecting area is called as aperture. The effective width or distance of the spherical mirror from which reflection of light takes place is called as it's a aperture. So you can see the aperture of a spherical mirror is shown as now if you see here, now let us consider that the where I have to draw. Okay, I will draw here. Utilize this space here. If you want, no, it's a single diagram where we can draw everything. Okay, for convex and concave, both I will draw. You decide means how you can to keep it. This is yeah, whatever you want, however you want. It's okay, I will draw, no problem. Okay, because drawing is the most important thing. Now this let us assume that this is a sphere. This is a spherical mirror and this part is being cut down. So where will the center will be? Here the center will be. And what will be the aperture? The aperture will be this area. So this area is the aperture width. This is the width, right? This is the available area. This is A. A for aperture. This is the aperture width. Distance. Not angular distance. It's the radial distance. Okay. So what happens? Even though it is a convex mirror or the concave mirror, the aperture will be same. Justified. The amount of rays falling on the aperture depends on them, falling on the reflecting surface depends on the aperture. If the aperture is constant for both convex and concave mirror, that means that the same amount of rays will be entering on both the convex and concave side. Okay. You can see here he has taken this side for the concave. Okay, this is the center. So this is the aperture for convex mirror. Okay, that is the aperture for convex mirror. Now this is concave, this is convex. Second term is pole. What is this pole? The center of the reflecting surface of a spherical mirror is called its pole. The center of the reflecting surface of a spherical mirror spherical mirror is called pole. So how to identify the pole? How to identify the pole? Simple thing. The amount, if this is the mirror two ends, let us take it as x and y. This is also x dash y dash. Okay. If this x and y, now you know what is the arc length. It's a half. Wherever it is the half, that means the half of the reflecting plane. That is the center. So that point represents the pole. This is the pole. Okay, write it as xy only. It's a pole for the mirrors. Next, center of curvature. Very, very important. Center of curvature. Already I told the geometric center of the hollow sphere of which the spherical mirror is a part. That means the geometric center means the actual center. Already in the main diagram I draw that center. That is the center of the curvature. Okay. So I'm going with the definition. The geometric center. Geometric center, because here the pole may vary also. Why? Because if you take a shape of like this, the pole will come here. But geometric center will always be at its geocentric position. That is the main important thing. You should understand. That's why geometric center name came. Of the hollow sphere of which the spherical mirror is a part. Right? Is called the center of curvature. Center of curvature of a spherical mirror. Already I have drawn, I have pointed. See, center of curvature. Okay, you have to imagine this. This you will not be given directly. This will be given. You have to imagine this when you have to complete the circle and form the geometric center. Next, radius of curvature. Radius of curvature. What is the radius of curvature?
Maybe a line joining center of curvature and pole.
Very good. This is a radius. That means for a circle, a hollow sphere is also a circle. So in that circle, all the radius will be uniform. That radius is the radius of the curvature. Correct. Same thing. The radius of the hollow sphere for which actually English is very, very important in competitive exams. Because it's for that. Okay, of which the reflecting surface is a part. Is called radius of curvature. So line joining CP. So I am joining CP here. Here also I am joining CP. So this is the length CP. Example. CP equal to R. R means radius. of curvature. Okay, that's over. This is a distance parameter. These are constants. This is a distance parameter. Next, principal axis. Very good. Principal axis. Okay. Shall I erase this for writing? Or you want me to write below? It's not an issue. Principal axis. I will write below. One of them I will write below. Very, very important. Principal axis. The straight line passing through the center of curvature and the hole. The straight line passing through center of curvature and bowl. Okay. Is called principal axis. So we represent the principal axis with a straight line only, but I am representing here till dotted line. But you can represent it as. So this is our principal axis. These are principal axis. For both the mirrors I am showing single go. Next is principal focus. Okay. Principal focus. Principal focus. What does it means? Principal focus is nothing but the focus point. We call it as a focus point in normal words. What is that means? The principal focus of a concave mirror is a point on its principal axis at which the light rays, when are coming from parallel and close to the axis, converge after reflection. So this principal focus will change. So principal focus has two different definitions according to concave and convex. In convex mirror, in concave mirror first. In concave mirror, it's a point on the principal axis where the rays of light after coming from infinity source converge after reflection. It is known as principal focus.
Focal point.
Yes, focal point. Why it? I will explain about that also. In convex mirrors, it is a point on it is on principal axis only. Beam of when light rays initially Parallel to, initially parallel to the axis, diverge. Okay, diverge after being reflected. From convex mirror. First, let me write, I will explain. Okay. Is principal focus. Clear? Now I will explain till these all terms other than principal focus. You have understood everything or not? First point. Clear, na? Okay. What happens is, I'll tell you. In a concave mirror, in a concave mirror, it is a point on the principal axis. It is a point on the principal axis. Principal axis is this, where the rays of light coming from infinity source. Infinity source. Infinity source, what I told yesterday, all the rays will come parallel to each other. When the rays of light are striking parallel to each other, they will converge at one point. That one point is on the principal axis. It is on the principal axis. Okay. That point is known as focus point. So it is a case also in when we are dealing with the different images observed, when different cases we will study about convex mirror, concave mirror, we will see that also. But for the time sake, you understand that if this is the infinity source, light is coming like this, all the light source lines are going parallel. So when they hit here, they go, one will come like this, another will go like this, this will go like this. So every thing which is coming from infinity is converging here. So this point is the focus point or principal focus for concave. Now what about convex? Now convex also same situation, right? Same situation, coming from infinity. Now these rays are coming. Now what happens? This is hitting like this and they are getting diverged. Okay. So their image present in the concave mirror will be formed. I told already, all the images that are formed are due to the reflecting ray. So the image formed will be here. This point is principal focus. Yeah, virtual image. Virtual image. That I will speak next. That topic only I will speak about that only. Those things only next I will speak. But predefinedly, I want to speak about this. Next, I will again explain plane mirror. These all in the next class when I will explain very clearly. But basically, we are going with this terminology here. Okay, clear till here? So that's what he has said. It is a point on principal axis when beam of light rays initially parallel to the axis, means it is coming from infinity source, diverge after being reflected from a convex mirror is principal focus. And one more important thing which you should understand here is, what happens is this principal focus always is half the center of curvature. Okay. So that we write here as one of the note for this, and write as a note. So what is this? We commonly called PF, principal focus, as a focus point, and it is known as, you see, it is known as, it is half the radius of curvature, right? Radius of curvature you know already. is half the radius of curvature. So the focal point equal to P by sorry, not R by 2, radius of curvature by 2. That means the center of, if this is the, if that C is the center of curvature, then our focal point will be exactly at the half the distance. Okay, that is the another important thing that you should know. Please write down.